So today we're talking about chain rule, and this is probably the biggest rule because it shows up all the time for the rest of the year. And then we'll see something similar when we get to integrals called U substitution. So chain rule is really important, and we kind of have to be on the lookout for it from here on out. So the first example, with what we know, find the derivative of y with respect to x if y is the quantity 5x plus 3 squared. So to do this, using the rules that I know, I would go ahead and square out this function to begin with before I find the derivative. So 25x squared, this is going to be plus 30x plus 9. And then dy dx would be 50x plus 30. So not too bad, but we run into a problem if this was 5x plus 3 to the 22nd, something I wouldn't want to expand out. Squaring a binomial isn't bad, but even raising it to a third power can be kind of annoying. So, you know, what if we had to do this? This is where the chain rule comes into play. So anytime you can rewrite a function, some function u, within a function, so it's like f of some sort of function u, you need the chain rule. So first of all, just decide if the chain rule is needed. Is this a function within a function? Or can you use some of the rules that we've used previously to just find the derivative? So if I said find the derivative of 3x plus 2 to the 7th, would you want to multiply this binomial times itself 7 times? No, this is an inner function and an outer function. So is chain rule needed? Yes. The outer function, I don't want to put it in quotes every time. Let's just do this. The outer function is the parentheses to the 7th. The inner function is the 3x plus 2. All right, so if you wanted to actually have it in terms of u, the u is 3x plus 2, and the f of u is the quantity u to the 7th power. For b, do I need to put this into a chain rule? So think about if I would have given this to you last week or even yesterday, how would you do it? This one we shouldn't need it. We can just rewrite the function as 2x to the negative 1. And then I don't need a chain rule. That's just the power rule that we have. So it would be negative 2 over x squared. So chain rule needed? No. For part C, we have multiple terms. Can we go ahead and take the derivative of both terms? Yeah, so we don't need chain rule for this because dy dx would be 2x minus sine x. And for the last one, we need chain rule for this because the outer function is just square root of this quantity in here, and the inner function is 3x squared minus 4x plus 1. Since we're not allowed to square root individual terms or anything like that, we would have to use chain rule. So the rule in general, the chain rule, there are a lot of ways to look at it, and you're going to use whichever one kind of makes sense to you. If you have some sort of composed function, so f of g of x, so some sort of expression beyond just a single x or something inside of your function, then your derivative is going to be the derivative of f with respect to g of x multiplied by the derivative of g of x. All right, so the derivative of the outer function with the inner function just along for the ride multiplied by the derivative of the inner function. And actually, I want to skip down to outer and inner for a minute. So again, if we have the derivative here, we have this outer function and an inner function. It's the outer derivative, outer prime, I'm going to write, of the inner. And then that's multiplied by the inner prime. In terms of, this was an old, like 2008 multiple choice type question, I believe. If it's f of some function u, if we have a function in terms of u, how can we get a derivative of y with respect to x? This is kind of a tricky thing. This is saying dy du. So think about what that's saying. That's the derivative of y with respect to u. And I keep saying that. What do I mean by with respect to u or with respect to x? It just means that's the variable that's in the function. So derivative, it's the same thing this says. Derivative of the outer function. And then in parentheses with your derivative and stuff, you might still have the expression u or g of x. And then that's multiplied by the derivative of u, the inner function, with respect to x. Derivative of u with respect to x. So that was an old AP question, which is kind of why, I mean, that's a complicated way to think of it in those terms. But when we use this derivative notation, this does simplify. Like you can kind of think of it as saying these du's cancel and you're left with dy dx. What if we just keep things in terms of u? So again, it would be the derivative of f with respect to u multiplied by the derivative of u. And if you want just more of a general thing, this is kind of how I think of it, honestly. Or I sort of think of these outer and inner terms, but I also think of this. If you have f of something, there's some sort of expression, something inside of a function, then it's f prime of the thing times derivative of the thing. So pick whatever makes sense to you. Maybe none of them make sense right now, but as we do some examples, hopefully it's going to kind of fall into place. All right. So again, if it helps you, you can kind of do some u sub. You can think of this. I'm not going to do it every time, but I am going to do it for this first one. So if this helps you, you can kind of think, okay, u is 3x plus 5 because that's the inner function. Let's rewrite this function in terms of u. All right, so what is the derivative? Dy dx. What's the derivative with respect to x? First, let's just take the derivative of u. It's 8 times u to the 7th. But then I have to remember to add this little u prime in here. All right, so what would u prime be? And let's go ahead and fill in what u is. So 8 times u is 3x plus 5 to the 7th. And then what is the derivative of u? So if this is u prime is just 3. So times 3. And then I would take that further. So dy dx, I don't want to have an 8 and then multiply by a constant on the end. I'm just going to make that 24 times 3x plus 5 to the 7th. All right, for number 2, I'm going to do the u thing one more time. And then again, I think it might be confusing. So if it is, you can just ignore this. But again, I'm saying let's let u be the inner function, 4 minus 3x squared. If it helps, tell yourself right now, what is u prime? Take the derivative of u. It's negative 6x. And then let's rewrite the function. This is just y equals u to the 7th. If I said take the derivative of u to the 7th, hopefully, you would say 7u to the 6th. And then the thing that you have to be careful of is we're not taking the derivative of y with respect to u. We're not finished here. We're taking it with respect to x. So now we need to multiply by u prime because u prime is the derivative of u with respect to x. That's why all of this is working. We take the derivative of y with respect to u, multiply that by the derivative of u with respect to x, and that leaves you with the derivative of y with respect to x. All right, so what is all this? 7 times 4 minus 3x squared to the 6th times u prime. We said that was negative 6x. And I always want you to simplify. If you have a simple monomial times another monomial, go ahead and simplify that. So negative 42x times 4 minus 3x squared to the 6th. They would expect you to take it that far, I think, on a free response. And of course, a multiple choice would probably look something like that. I'm going to drop this u notation, though, and just see if you can do it without, because you don't want to waste a bunch of time always writing out a u sub. It's okay if you're getting confused to do it, but I would just leave it like this for now. Okay, so we have a constant divided by 3x minus 1 to the fourth. We can still rewrite things. It would be smart to rewrite this as just a negative 4 power so that I don't accidentally do quotient rule or something. So I'm going to use the power rule, dy dx. The power rule says that I'm going to pull this power out in front. That would become 20. 3x minus 1 to the subtract 1, negative fifth power. Multiply it by the derivative of 3x minus 1, because that's the inner function. So multiply it by 3. And then simplify this. You have 3 times 20 is 60. And then let's get rid of our negative exponent. Make it over 3x minus 1 to the fifth. That's our dy dx. Next one, dy dx. So again, I'm just thinking, what's the derivative of the square root of something? It's 1/2 times 3x plus 1 to the negative 1/2 times the derivative of 3x plus 1, because that's the inner function, so times 3. And then I'll clean it up. There's a 3 in the numerator, and then the 2, and I like to write this as square root of 3x plus 1 should both be in the denominator. Okay, now we're getting a little tricky on these last couple. We have a nice simple quantity squared. The derivative of that is 2 times the quantity to the first power. But nested in here is this nice little quotient rule. So, and maybe this will help you if you want to do that. Well, no, you might want to do the u sub off to the side, but I don't think I want to. I think it's going to clutter my work too much. So here, the derivative with respect to u is nice and easy. It's pull the 2 out in front times this whole ugly thing to the first power. Okay, but we have to multiply it by the derivative of this fraction. And since I can't simplify the rational function, I have to use quotient rule. So quotient rule is low d high, derivative of 3x minus 1 is 3, minus high d low, derivative of x squared plus 3 is 2x, all over low, x squared plus 3 squared. Now, the calculus is done. The rest of this is algebra. We do not want to leave our answer like this. We need to clean it up a bit. So expectations for my quizzes and tests and hi. For my quizzes and tests, we have a visitor. And the AP exam is going to be to simplify this because they're not going to leave their answer in this form. Hi. So I would simplify this as 2 times 3x minus 1 over x squared. Bye-bye. X squared plus 3. She's okay. I'm going to distribute in the numerator. So 3 times x squared plus 3 is 3x squared plus 9. And then be careful with this minus sign and this 2x. You should be thinking, or maybe even rewriting this as minus 2x. You're going to distribute a negative 2x through the 3x minus 1. So anyway, that becomes negative 6x squared plus 2x. And then remember, in denominators, we do not want to FOIL out x squared plus 3 squared. That's our general rule. For probably 99.9% of the time, we do not FOIL that out. So, all right, so let's keep going. Now we're starting to get somewhere with this. I have 2 times a fraction. This is going to be times another fraction. So we can start consolidating some things. Like, see how we have x squared plus 3 here, and it's going to be multiplied by another x squared plus 3 squared. So let's go ahead and put this whole thing over x squared plus 3 cubed, because that's what we would get when we multiply those. And then I have a 2, and I have a 3x minus 1. I'm not distributing that yet because I'm waiting to see what I have up here. So what do I have up here? I have negative 3x squared plus 2x plus 9. Okay, and I think I would stop here because the same argument I was talking about in previous days of notes, I could maybe factor this trinomial. I'm not sure if it does off the top of my head, but even if it did, it's not going to cancel with an x squared plus 3, so I don't really have to waste my time bothering with that. The only time I would work on this anymore is if I'm finished and I don't see my answer in the multiple choice options. I would try to see if an equivalent answer to mine is in there, like if something's been distributed or factored. All right, what about number 6? We do have an inner function here. You can't distribute an x squared through a square root or anything like that. So we are going to have to use product rule for this one. And within that product rule is a little chain rule piece when we go to take the derivative of the second part. So f prime of x, using the product rule, it's the first function times the derivative of the second. So, okay, what is the derivative of the second? This is, remember, this is 1 minus x squared to the 1/2. So it's 1/2 times 1 minus x squared to the negative 1/2 times the derivative of 1 minus x squared, negative 2x. So that's just the derivative of the second function plus the second function. I think since this is in exponent form, I'm going to go ahead and write this as 1 minus x squared to the 1/2 because we're probably going to be factoring this, times the derivative of x squared, which is 2x. And then let's clean up what we have first, and then we'll think about factoring. So in this first term, this big long term, you have a 1/2 and a negative 2. So those cancel, but don't drop the negative sign. This is negative x times x squared. So negative x cubed times 1 minus x squared to the negative 1/2 plus, let's just put this 2x out in front, 1 minus x squared to 1/2. Now, if I'm working on my own, maybe I would stop here. But again, most of what you're going to be doing with this is either trying to set it equal to 0 to solve or trying to find your answer in multiple choice. And they're probably not going to leave their answer like this. So whether you're setting equal to 0 and solving or trying to find an equivalent answer, you're going to need to factor a GCF out of this to be able to do either one, to find the correct answer or to actually set it equal to 0 and solve for x. So the GCF, actually, I'm going to write that leave a space here so you have room to show work if you need to. The GCF on these outer pieces, you can take out an x or a negative x. It doesn't really matter. I guess I'll go with a negative x, see what happens. And then when you have 1 minus x squared in both parentheses, remember, when you're factoring something out, you always factor out the smaller of the two exponents. Like I took out an x, not an x to the third. So if I'm choosing between negative 1/2 and 1/2, negative 1/2 is smaller. So I should be factoring out a 1 minus x squared to the negative 1/2. And then you're going to have to figure out what you have left after you do that. So the reason I left a space here is because sometimes it's helpful to go ahead and show yourself that factoring out a GCF is just dividing each term by the GCF. So this can kind of help keep things straight and organized as far as like what you should be getting here. So since I chose a negative x, this is going to divide out to positive x squared, and then the x minus, or the 1 minus x squareds to the negative 1/2 cancel. And then 2x divided by negative x is minus 2. And these exponents, 1/2 minus negative 1/2, will add up to 1. So I have negative 2 times 1 minus x squared to the first power. All right, and maybe we'll go ahead and get rid of our negative exponent by moving this down here. And then we'll look at what we have here. Let's see. This is negative x times x squared minus 2 plus 2x squared. So we're almost there. Negative x times 3x squared minus 2 over 1 minus x squared to the 1/2. or square root of that, whatever. And again, how do I know that I need to go that far? You will mostly be, you'll mostly be looking for a multiple choice answer that would probably be in this form. So you'll notice when you get to this point that you can't stop because none of the choices look like that. But also, more likely, if it's a free response part, you'll be using this derivative to set equal to 0 or equal to some sort of number. If it's equal to 0, we would only be able to solve once it's in this form anyway. Okay, number 7. This looks like a quotient rule because I can't simplify anything out. You could turn it into a product rule if you want to make it x times x squared plus 4 to the negative 1/3, but I don't really see much benefit in that unless you really hate the quotient rule. So let's just try quotient rule. F prime x. I almost did something. I just started writing equals. You don't want to just write equals without at least starting it with an f prime x, because otherwise you're saying like what you're about to do is equal to the original function, and that would be a mistake. So f prime x equals low d high, that's nice and easy, minus high d low. This is going to be more of a problem. Remember, low is not to a negative exponent. It is just x squared plus 4 to the 1/3. So when I take the derivative of the bottom function, it's 1/3 times x squared plus 4 to the, when you subtract 1, negative 2/3 times the derivative of x squared plus 4, which is 2x. So that was low d high minus high d low all over low low. Now when you square something to the 1/3 power, remember power to a power means you multiply 1/3 times 2 and you get 2/3. All right, so let's work on cleaning this up. First of all, I don't need the 1 right here. So x squared plus 4 to the 1/3. And then I have a negative x times 1/3 times 2x. So let's make that minus 2/3, excuse me, x squared times x squared plus 4 to the negative 2/3 all over x squared plus 4 to the 2/3. All right, it's not great having that 2/3. That's like a fraction within a fraction here. So I think I'm going to do this now. Why don't we go ahead and multiply by 3 just to clear out that fraction. So you don't have to do that, but you might do that if you are looking through multiple choice answers and realize none of them have a 2/3 in there. So if you're going to do that, just be careful. 3 gets multiplied out here. So 3 times x squared plus 4 to the 1/3. This is now just minus 2 x squared times x squared plus 4 to the negative 2/3 over 3 times x squared plus 4 to the 2/3. Let's bring our work up here. So I'm going to use the same idea as I did last time, where in the numerator I have this GCF. So I'm going to factor out the 3 and the 2x squared have nothing in common. I'm just going to factor out an x squared plus 4 to the negative exponent. Negative 2/3 is smaller than positive 1/3. So factor out a negative 2/3. And then what are you left with? I like to do square brackets. What are you left with when you do that? You still have the 3. 1/3 minus negative 2/3 is 1. So times x squared plus 4 minus, you still have a 2x squared. And then this second part of parentheses will cancel out. It's still all over 3 times x squared plus 4 to the 2/3. And then here's where things consolidate a bit, because in the numerator you have x squared plus 4 to the negative 2/3, which will move down to the denominator. And when you multiply two like bases, with exponents, you add their exponents. So in the denominator, you have 3x squared plus 4 to the 4/3, once I move that down. And then up here, because I don't want to write 2 lines of work, I'm going to show myself what I would have if I distributed, and then say that would be x squared plus 12, which is not going to be able to cancel with anything, so I'm going to leave it like that. That's about as bad as it can get. What about trig functions? Those don't go away. So we still need to, if you haven't started studying your trig derivatives, you need to start doing that. But we need to determine first if we're looking at a trig function that needs chain rule or not. So remember, you need an outer and an inner function. If I just have 2 times cosine of x, I don't need chain rule to take that derivative. The derivative, let's just call it y prime. The derivative would be -2 sine x. For part B, if it's tangent squared x, remember, that's the same as tangent x, the quantity squared. So yes, we need chain rule for that. The outer function is quantity squared. The inner function is tangent x. For part C, the squared is on the angle x. So yes, we need chain rule again because the outer function is sine of a quantity and the inner function is x squared. So anytime you have an angle that's not just a plain x, now you have an inner function. All right, cosine of 2x, same thing I just said, the angle is 2x. So yeah, the outer is cosine of something, and the inner is 2x. All right, use the chain rule to find the following derivatives of the following functions. Let's see. So if it helps you, write this as sine x, the quantity squared. So the derivative of y with respect to x is first the derivative of the outer function. So if you have something squared, that's going to be 2 times that thing to the first power. Multiply that by the derivative of sine, which is cosine. I don't really need those parentheses, so it's just 2 sine x cosine x. All right, for number 2, tangent of x squared. So first we need the derivative of tangent x. Remember, that one's secant squared of the thing, x squared. And then we need to multiply that by the derivative of x squared, which is 2x. To clean up these answers, the x squared is the angle, the 2x is not. So put the 2x out in front times secant squared of x squared. You don't have to have parentheses after or around x squared, although you could if you choose to. Secant of 3x squared. Now I would make this the secant of just 9x squared. Might as well just do that, because otherwise you're going to have like 2 rounds of chain rules on that. You'd have to chain on the squared angle and chain on the 3x. Okay, so the derivative, let's call it y prime. Derivative of secant is secant tangent. So secant of secant of 9x squared, tangent of 9x squared. And then we have to multiply that by the derivative of 9x squared, which is 18x. I'm going to put the 18x out in front. A really common mistake, but a totally illegal mistake, is to try to like factor out a 9x squared or something. Remember, whatever is in the angle of a trig function is locked into it. You can't start factoring things out. So just be careful. All right, so this is sine of 4t cubed. My first derivative is, first step in the derivative is going to be to make it 3 times sine of 4t squared. And then the next outer function, or the next thing I'm doing the derivative of, is sine of 4t. So the derivative of sine is cosine of 4t. But you're not done, because there's another function nested in there. That's the derivative of 4t, which is 4. So to clean that up, you have a 4 times a 3, 12, times, let's just write this as sine squared of 4t times cosine of 4t. That was like a triple composite function. That was saying we have one function 4t, nest that inside of a sine function, nest that inside of a x cubed function. Same thing here. Remember, this is tangent of this thing cubed. So the first derivative that you take, the first step, is to do the power rule. 3 times tangent of 5t plus t squared. The next step is to take the derivative of a tangent function. That is secant squared of the angle, 5t squared, plus t. The next step is to take the derivative of the 5t squared plus t. So that is 10t plus 1. Okay, the only thing I can do, I think, to clean this up and like drop a set of parentheses is I have the quantity tangent squared. I guess I'll make it, I think I'm going to do a couple of things actually to rearrange. I've got a 3. I like that. I want to put this non-trig part out in front too. And then I'm going to make this tangent squared of 5t squared plus t. And then it's going to be secant squared of 5t squared plus t. Again, is it wrong to leave it like this, my first step? No, you just have to be able to search for and find the correct answer that's equivalent to yours. Or work with what you have if you're then setting this equal to something. This would be a calculator problem if we were trying to set it equal to something. And before you dive into number 6, don't do quotient rule if you're just dividing by a single term. There are 2 things I could do. 1 over cosine is secant squared. Cosine squared over cosine squared is 1. So this is secant squared minus 1. Or 1 minus cosine squared is sine squared. And sine squared over cosine squared is tangent squared. If I do what I said before, secant, if you divide it out, secant squared x minus 1, that is tangent squared. So either way, you get to the same place. So now it's just take the derivative of tangent squared. So first you're taking the derivative of something squared, which is 2 times that thing to the first power. And then technically, I would be taking the derivative of the inner function, which is just x. So times 1. So this one doesn't really need a chain rule, but we're in that mode, sort of. So, chain rule works for everything, whether you need it or not. It's just that when the inner function is just x to the first power, the chain rule doesn't really matter. So that is the derivative for this function. Oh, sorry. I skipped a step. Chain rule does matter. 2 times tangent of x. I never took the derivative of tangent. Sorry about that. Secant squared x. Now it's the x that, if that's technically the inner function, so I don't need to take the derivative of that. Excuse me. So that's 2 tangent x secant squared x. Okay, some practice just rewriting things that look very similar, but they're all slightly different. So cosine of 3x squared, the derivative of cosine is negative sine of the angle. Now I have to multiply it by the derivative of 3x squared, which is 6x. I'm not going to work on simplifying these. For the next one, cosine squared, cosine of 3x, the quantity squared. So the derivative of b is 2 times cosine of 3x. And then I have to take the derivative of cosine, which is negative sine of 3x. And then I have to take the derivative of 3x, which is 3. And for the last one, I would make this cosine of 9x squared before I dive in. The derivative of cosine is negative sine. And the derivative of 9x squared is 18x. And I could simplify those as needed. All right, so chain rule can be confusing. Sometimes rewriting with parentheses to show what's being squared works. You can try the u sub thing if that helps. But we've got practice for these chain rule problems. Now, on this practice, this is going to be taken for a quiz grade. So you can work on some tonight. You've got all day in class tomorrow. And then it's due the following day. I actually encourage you to work with each other, but don't just copy from each other, because if you can't master chain rule, then you're done in this class. There's no way that you'll survive BC if you can't get the hang of chain rule, and it just takes practice. It's not going to, for some of you, it might not click right away, and that's okay, but you need to get the hang of it and you need to recognize it. So doing all of these problems on your own, checking with somebody and really working through and understanding the ones that don't match up, that's going to be the best way to get out of this assignment what you need. I mean, sure, it's a quiz grade. I expect them all to be high grades since I'm allowing you to work together. But what I really want you to do is make sure that you fully understand what this chain rule is supposed to be. All right, stop into office hours if you need help.